All right, this is where we ended yesterday, right? Okay. Any questions after doing your homework on finding the greatest common factor? Difference of squares? Did you have any sum of squares on your homework? No, right? Because we can't factor them. And then what about difference of cubes or sum of cubes? Pretty good on those? Yeah? Especially if you have this to glance back at, right? Okay. So let's go here for today's notes. Today we're going to factor by grouping. Now, I could have had this in yesterday's section, right? But to be fair, yesterday's section was already pretty long with all those other things that we talked about. This one, I'm going to give you the general form, and I'm going to give you 2 examples because you're going to be good at it. So I could have grouped it with yesterday's, but here's the deal. Not counting greatest common factor, okay, but looking at difference of squares, sum of squares, difference of cubes, and sum of cubes, what was true about all of the problems yesterday? Excuse me. How many terms did they have? Yeah, all the problems yesterday had 2 terms, right? So factoring by grouping is different because factoring by grouping is going to have 4 terms. So do you see why why I might have wanted it on a different day, right? I kept all the things with 2 terms together, so now we're going to go with 4 terms. What did I skip? 3? Okay. We'll do that tomorrow. It's okay. I really want to do this today first, and I think you'll see why tomorrow I wanted to do this today first. Okay? So here's what we're going to start with. X cubed plus x squared plus x plus 1. And just so you have a general idea of how big or small you need to write, we're going to have 1 example on this page, and then I'm going to have 2 examples on this page. Okay, so I'm going to write pretty big on this side so we get the general idea over here, but on this side we're going to have to write a little bit smaller. Is that fair? Okay. So when we're factoring by grouping, you're going to know that you want to try factoring by grouping when you have 4 terms. Okay? When there's 4 terms, you're going to want to try to factor by grouping. Okay? Now when we factor by grouping, wouldn't it be a lot easier if there was not 4 terms, if there was only 2? Yes, so that's what we're going to look at, okay? We're going to pretend there's only 2 terms. And I'm going to say, what is the greatest common factor in these 2 terms? Now, normally we can't do that, right? We can't just isolate parts and take out greatest common factor there, but that's the whole idea when there's 4 terms, factoring by grouping, okay? So what is common in these 2 terms? What's the greatest common factor? X squared. Is everybody in agreement on that? So if I factor out an x squared, what is left? Divide this term by x squared, and what do you get? X. Divide this term by x squared, and what do you get? 1, right? Okay so far? So what I did was I grouped them. Let me just draw some lines. I grouped those 2 together, and I grouped those 2 together, right? So first I said, what's common in those 2? We said x squared, so we factored an x squared from each term, or divided an x squared into each term, and this is what I had left, right? Now that I'm done with that, now I'm going to ignore that side and just look at this side. What's the greatest common factor in these 2 terms, knowing that you have to factor something out?
1.
Yes, 1. Right? 1 is the only thing I can divide out of each term. Now, normally if it's a 1, do we have to write it? No, right? But when we're factoring by grouping, we do. Okay? So I'm going to factor out a 1. Well, what's left if I divide x by 1? X, because anything divided by 1 is itself, right? And what's left if I divide a 1 by 1? 1. Okay so far? Okay, look what I have left now when I uncover both sides. What do you notice? Yeah, these are the same, aren't they? So we're going to group again. This is one term, and this is one term. What is common in these two terms? X plus 1, right? And x plus 1 is common in both terms. Oh, what in the world? If I factor out an x plus 1, what's left? X squared plus 1. X squared plus 1. Done.
Does it matter how you write it down? Like, what if I put x squared plus...
Can you hold on just for a second on that question? It's a good question. I want to wait for just a second to answer it. Okay? Everybody okay so far? That's just our very basic one that I wanted to start with. Okay? So I group 2 and 2. I factor out a common term in the first 2, factor out a common 2 in the second 2. What's my goal? To get the same parentheses, right? So in some of these problems, it's kind of tough to see what the greatest common factor is at first, right? But if you see that you need an x plus 1 in the parentheses for the second one, that might help you figure out what to factor out. Especially if it's numbers we're not familiar with. We don't work with 7s a lot. 7s are annoying, right? But if we can know what our parentheses should be, then that helps us know what to factor out. Does that make sense? Okay, let's go to this side and do 2 examples over here. 3x to the third plus 6x squared minus 4x minus 8. So I'm going to group the first 2 together, and I'm going to group the second 2 together. Okay? What's common in the first 2 terms? 3x squared. Does that make sense to everyone? Everybody okay with that? So if I factor out a 3x squared, what's left? X plus 2. Everybody okay with that? Now, what's common in the second 2 terms? 4. Okay, I agree with 4, but think ahead. If I factor out a 4, are my parentheses going to match? No, they won't, right? So what do I need to factor in instead? A negative 4. That's exactly right, a negative 4, right? So if I factor out a negative 4, now what's left? X. Negative 8 divided by negative 4 is a positive 2, right? You okay with that? Everybody good? Now looking at these 2 terms, 1 and 2, what's common in those 2 terms? X plus 2. And what would be left over if I factored out an x plus 2? Okay, so 3x squared minus 4, and we factored out an x plus 2 from each term. What did I just do different? Isn't that what he was asking a minute ago? Yeah. Is that okay if I write it that way?
Yes.
Guys, does it matter what order we multiply in? It does not, right? I couldn't put x minus 2 here. That would be different. That would change everything. But if I put x plus 2 first and then 3x squared minus 4, or if I put 3x squared minus 4 first and then x plus 2, you know that doesn't matter, don't you? Okay? Now I need to ask you a what-if question. Before we go on to the next example, I need to ask a what-if question. Are you okay with that? What if when I did this problem, that's actually what I got? Like I did everything right, ignore what's there, but if I did everything right and that's what I got as my answer, am I done? Why not? Oh, this can be factored? Why? It is the difference of squares. Yes, it is. Okay? So if you try to put this in, it's going to tell you you're wrong, except you're like, I'm not wrong. I know that that's right. Remember what the directions are always going to say. Factor completely. This is factored. I'm not disagreeing with that. That's factored, but is it factored completely? No, if this isn't factored into what would it be? X minus 2 and x plus 2, right? And then along with this other x plus 2, that would be factored completely. Does that make sense?
Right.
Any questions about that? Okay, let's do one more example to make sure we're understanding this. I'm going to talk less this time. Okay? 5x to the 4th minus 15x to the 3rd plus 7x minus 21. All right, what do you want to do? So you think in the first two terms the common factor is 5x squared? Or 5x cubed? Are you okay with that? Yeah? Okay, so 5x cubed. What do I do now? Okay, tell me. X minus 3. I agree with that. Now what? Do the next one, okay? Tell me what to do.
Greatest common factor is 7.
Greatest common factor is 7. And if you didn't know that for sure, could you look at this parentheses right here and know that inside the parentheses I need an x? So the only way to get that it would be to factor out a 7. Yeah, okay. So what's left?
X minus 3.
Okay. Now what?
And then you find the greatest common factor I know.
So what do you want me to write?
5x
5x cubed plus 7. All right. X minus 3. Any questions? All right, I have another one for you then. Okay. What if, another what if question, right? What if I did all this and I factored out a 7 right here, so we're going to ignore the problem, right? I factored out a 7 right there, and right here I got a 4. That would be weird. What would I do?
Give up.
Give up and cry? Okay, we don't want to do that. Okay, we don't want to do that. Yes, sir. What would you do?
Could you like multiply it, both of them by like, a different number?
That would be a good thing to think about, but I can't. So good try. If my parentheses are different, can I keep going? No. If my parentheses are different, can I factor by grouping?
No.
No. Okay? Now, that's not going to happen today, but it might happen Friday or Tuesday.
Wait, so is that.
Okay? It might happen Friday or Tuesday. And if I can't factor by grouping, I have to find another way. Okay? If you try this and your parentheses are not the same and you haven't done anything wrong, then you have to stop. You can't factor by grouping. Does everybody understand that? Any questions? Any questions on any of these examples for factoring by grouping?
No.